Okay, so simplifying rational expressions. Now remember, we talked about examples of rational expressions last class period. For example, here's an example of a rational expression. X plus 3 divided by 2x minus 1. That's an example of a rational expression. And we looked at many more last time. Basically, though, a rational expression, if you recall, is just a polynomial divided by a polynomial. And so last class period, we evaluated these rational expressions. Remember where we said let x be 4, y be negative 2, things like that? And then you also now know that you can also determine where a rational expression is undefined. So for example, if I want to find out where is x plus 3 divided by 2x minus 1, where is this rational expression undefined, what would you do? Where's a rational expression undefined? When the denominator is 0. So what's my denominator? 2x minus 1, and set that equal to 0. So I find out where is that equal to 0. So you add 1 to both sides. So you get 2x equal 1. Divide both sides by 2. So x equals a half. So x equal a half makes my denominator 0. It makes this rational expression undefined. Because what's 2 times a half? You can check. What's 2 times a half? 1. And what's 1 minus 1? 0. All right. So the restriction would be that x cannot equal what? 1/2. All right. So we looked at that. So we looked at evaluating these rational expressions. We looked at determining where is this rational expression undefined. Now we're going to look at simplifying rational expressions. So that's the next goal, is to simplify these rational expressions. So let's talk about simplifying rational expressions. Before you can simplify rational expressions, you got to know what we mean by simplify. So in the previous courses, a long time ago, you learned how to simplify something like 4/8. What do I mean by simplifying 4/8? What does that mean? Reduce. And so if you look at the numerator and the denominator, what is the largest factor that they have in common? 4. And so basically what you said was this. You said 4 into 4 is 1, right? And remember, you put a 1 in its place, right? Okay? And you said 4 into 8 is what? 2. And so you rewrote this as what rational number? 1/2. And that's what you did. Number 2, suppose this time I had 3x divided by 6. So let's see if we can simplify this rational expression. Can you simplify this? Yeah. What part of this can you simplify? The 3 and the 6, right? So what do 3 and 6 have in common besides the number 1? 3. So basically what you said was this. You would say 6 divided by 3 is 2. 3 divided by 3 is 1, right? Now let me tell you how to write the answer. So I expect you to know that something like 1 times 5 is what? 5. 5 divided by 1 is what? 5. So you need to know those things. So when I say 1 times x, I need for you to know that that is just what? X. So you're going to say x divided by, and then what's the denominator? 2. So that's how you're going to write the answer. You're going to write it back as a rational expression. So you have a numerator and you have a what? Denominator. So in my numerator is the factor x, and in my denominator is the factor 2. So don't say 1 times x, just say what? X. All right, number 3. Suppose you had xy divided by xz. That's a z. xy divided by xz. Now, how many factors do you see in the numerator? 2. There are 2 factors. Remember, factors are separated by the product, by the multiplication symbol. So when I read this as x times y, right? So your first factor is x, your second factor is y. What about the denominator? How many factors? 2. They are x and z. Do you have any common factors? The x. So if you look at the numerator, I have a factor of x, and the denominator have a factor of x. So it's kind of like saying in a previous course when I had 4 divided by 4. What's 4 divided by 4? 1. Because basically what you said was this. You said 4 goes into 4 one time, 4 goes into 4 one time, and 1 divided by 1 is 1. Same idea here. X goes into x 1, x goes into x 1. You see the same idea? So make sure you use connections from previous courses. And then let's talk about how to write the answer. So what is going to be the answer, though? Y divided by z. So y divided by z, because 1 times y is y, 1 times z is z. So make connections between your previous experiences. Okay, number 4. You have x squared y divided by x. X squared y divided by x. Okay, let's talk about factors. If you look at the numerator, I see an x. How many factors of x are there? 2. How many factors of y do you see? 1. In the denominator, what's the only factor you see? X, and occurs how many times in the denominator? 1. All right. So what you might want to do to begin with is, and again, the more you do, the better you get at this. But let's think about the x squared. So x squared means x times x. The denominator is an x, right? So I'm not looking at the y just yet. I'm just looking at the variable x. So if I had this, make a connection between stuff you know how to do. If I have 4 times 4 divided by 4, so meaning 16 divided by 4, right? You all know that 16 divided by 4 is 4. But if you leave it as 4 times 4, what can you reduce? How many 4s in the numerator?
2.
There are 2, but how many can you reduce with the denominator?
1.
Just 1. So you'd say 4 into 4 is 1, 4 into 4 is 1, and you're left with what? 4. Same thing here. Can I reduce this x with both of these or just one of them?
1.
Just 1. So x and x is 1, x and x is 1. And you're just left with what? X. So let's talk about this again now. How many factors of x is in the numerator? 2. How many factors of x in the denominator? 1. So I can reduce how many? Just 1. So that means this is a 1, and I'm left with x to the first power, which is just x, right? Can I reduce any y's?
No.
No. So what's the answer?
XY.
xy. Now, I just want to write this first part out. So if you look at it, you're going to say xy divided by what?
1.
1. But again, the denominator is a 1, so I expect you to just say this is just what?
XY.
xy. That's what I expect you to say. Okay? All right, let's do number 5. Number 5, let's suppose we had this. Suppose I had 3x squared y cubed divided by 2xy. 3x squared y cubed divided by 2xy. So if I go back to the numerator and listen to the words, what's the first factor that I see in the numerator? A 3. Will that 3 reduce with any factors in the denominator? No. What's the next factor I see? X, and occurs how many times? Twice. Will one or more of these reduce with anything in the denominator? Yes. So in your mind, you have this. Let's think about this. You have x times x divided by what? X. So I can reduce this x with one of these. And what are you left with? X. So let's talk about this. So this is going to be a 1, and this will be, how many will I have left?
1.
Just 1. I'm going to have 1 left. So you see that x to the first? I have 1 left. I had 2, but when I reduce it with the one that's in the denominator, I'm left with how many? 1. Okay, let's talk about the y's now. How many factors of y are in the numerator?
3.
3. How many factors of y in the denominator?
1.
When I reduce them, I have how many factors left?
2.
2. Very good. So you're going to say y, that's going to be a 1, that's going to be a what up here?
2.
A 2. Kind of makes sense because look, if I wrote it out, that's y times y times y divided by what?
Y.
Y. So one of these divides out and you're left with y times y, which is y squared. Okay? All right, so what's going to be the answer then? 3xy squared divided by
2.
2. So 3xy squared divided by 2. Okay, number 6. All right, now remember, as we did this, we talked about those in terms of factors. Factors. So look at number 6. Suppose you had this. X plus 2 times x plus 5 divided by x plus 2. X plus 2 times x plus 5 divided by x plus 2. So if I look at the numerator, what do you notice about the numerator in comparison to the others? Okay, it's already written as factors, right? Except when you look at number 5 rather, these factors were monomials. 3 is a monomial, x is a monomial, y is a monomial. Here, this is a binomial. Okay? This is a binomial. So when I look at these in terms of factors, how many factors do you see up here? 2. Remember, we're reducing factors. So my first factor is what? X plus 2. Do I have a factor of x plus 2 in the denominator? Yes, so I can reduce it. Now, let me remind you something. Don't just cross these out, because you know that in this place, when you divide out, what factor should be left? 1. You gotta make sure you put the 1 there. Your next factor C is x plus 5. Will that reduce anything down there? No, because you don't see an x plus 5, do you? So what's the answer? Or just x plus 5. So remember, if the denominator is just a 1, just write as the numerator. Okay, number 7. We have 12 divided by 9x minus 6. 12 divided by 9x minus 6. All right. What's the only factor you see in the numerator, or the only term you see? 12. Will that 12 reduce to anything down there? The 6? You think the 6? All right, I'm going to ask you this then. I'm going to ask you this. Suppose I gave you this. I said we have 4 divided by 5 minus 2. Okay? And using that same thing you just told me, using that same idea, you're probably thinking, well, that 4 can reduce with this 2. Because that's what you said here. You said I can probably reduce the 12 and the 6, right? That's what you told me. Well, let's see if we can. We all know that this is really 4 divided by what number?
5 minus 2. Which
Which is 3. So you all agree that's 4/3? So we all know that's equal to 4/3, right? That's a true statement. I'm going to go ahead and rewrite this. Based on what you just said, is it true to say 2 to 2 is 1, 2 to 4 is 2?
No.
Is that right here still 4/3? No, that's now 2 over what? 5 minus 1, which is 4. So you know you can't do that. You got to remember now that you can only reduce factors. You can only reduce factors, and factors are separated by what factors separated by the operation multiplication. Something times something times something times something, and so on. When I read this, this is read as 9 times x what? Minus 6. So the 6 is not a factor then. Okay? So no, you cannot reduce the 12 and the 6. You cannot even reduce the 12 and the 9. You could reduce the 12 and the 9 if that 6 wasn't there. Notice the difference. If that 6 wasn't there, then 9x is written as factors. 9's a factor, x is a factor. But the fact that you're subtracting something from it makes the 9x no longer a factor. This whole thing has to be put together. All right, so knowing all of this discussion right now, let's go back to number 7. What can you do to the denominator? On your test yesterday, some of you said nothing. Okay, let's talk about this again now. On your test that you just took, and I asked you to factor 9x minus 6, what would you have done? Factor out of 3. So the first step you need to do with all of these is, first thing you need to do is to factor. Factor. So step 1 is to factor. Now in problems 1 through 6, we didn't have to do that. Because in problems 1 through 6, they were already written as factors. They were already written as factors. Look, 3 times x squared times y cubed divided by 2 times x times y. At any point, did you hear me use the word add or subtract? No. Same thing here. X plus 2 times x plus 5. Did you hear me say x plus 2 minus x plus 5? No. What was the operation? Multiplication. When I come down here, though, this is 9x minus 6. So now what you want to do is now see if you can factor the numerator and factor the denominator. Well, the numerator is already just one term, so leave it alone. But the denominator is a binomial. Whether it's a binomial or trinomial or a polynomial with more than 3 terms, what's the first thing you always have to check for? GCF. What's the GCF here? 3. So this becomes 12 divided by 3 times what?
3x minus 2.
3x minus 2. Now can I reduce anything?
Yeah, 3.
The 12 and the 3. Because now I'm going to ask you what your factors are. What are now the factors of the denominator? 3 is one of them. What's the other? 3x minus 2. Will 12 reduce with any of these factors? Yes, this 3 right here. So 3 to 3 is 1. 3 to 12 is 4. Can I reduce anything else? So you're telling me I cannot reduce the 4 and this 2? Yes or no?
No.
No, you cannot. We just had the discussion. We just had the discussion. I was just checking to see if you were paying attention. So no, because 2 is not a factor, because you're subtracting it from this term 3x. So I get 4. The answer is going to be 4 divided by what factor? 3x minus 2. So 3x minus 2 is considered a factor itself. 2 is not a factor. 3x is not a factor. But what's the factor of the denominator? 3x minus 2. What's the factor in the numerator?
4.
4. All right, so that's the answer for number 7. So remember, the first step is to factor, and then the next step is to reduce. So factor, reduce, factor, reduce. And then write your answer. Okay, number 8. Suppose we had x minus 6 divided by x squared minus 36. All right, got to show the work. So first of all, what's the first step we have to do? Factor. Can I factor the numerator? No, if x minus 6 was on your test and I said factor, you would say, cannot be factor, it would be prime, right? What about x squared minus 36?
Yeah.
What kind of factoring is that? Difference of two squares. So when I factor that, I'm going to x minus 6 in the numerator. What's going to be the denominator?
X minus 6 times x plus
Okay, x minus 6 times x plus 6. Now notice, what factors can I reduce?
x minus 6.
X minus 6. Now, if I reduce the x minus 6, can I just cross them out like that? No, because if you did, here's probably what's going to happen. You're going to say the answer is just x plus 6 because that's all you see, right? But it's not x plus 6. It's what? 1 divided by what? X plus 6. So be careful. That's why it's important that when you cross factors out, that you realize that there's got to be something there. You got to have a factor still listed. You can't just cross it out.
Only when the x is the numerator.
Huh?
Only when the x plus 6 is the numerator.
Yeah, so she's asking this. She's asking, what if you had this? What if you had x minus 6 times x plus 6 divided by x minus 6? Now this time, the answer is what? X plus 6. Because what's in the denominator? 1. X plus 6 divided by 1 is what? X plus 6. Okay, so notice the difference between the two.
So it's just like number 6 we did, that's just the opposite.
Yeah, number 6, the same idea. The denominator was what? 1. So x plus 5 divided by 1 is what? X plus 5. Okay? But 1 divided by x plus 6 is not x plus 6. It's kind of like saying this. We know that 6 divided by 1 is what? 6. But 1 divided by 6 is not 6, right? It's actually 1 over 6. All right, number 9. All right, suppose in number 9 you had this. You had x minus 5 divided by x squared minus 8x plus 15. What's the first step? Factor, okay. Can I factor the numerator? No, but can I factor the denominator? Yeah, so the numerator is going to stay x minus 5. Let's look at the denominator. So let's see, x, 5. Let's try 5 and 3. The last sign's positive, so that means these signs in here have to be the same, and they're both going to be negative. And if you check it, the outer and the inner, what's the outer? Negative 3x. The inner is a negative 5x. When I add them up, do I get a negative 8x? Yeah. So I factored correctly. Now, once I factor, what's the next step? Reduce. Can I reduce anything? What factors can I reduce? All right, so x minus 5, and when I reduce them, they become what factors? 1. So what's the answer? 1 over x minus 3. Okay, so that's number 9. Okay, let's look at the next one. All right, let's look at 10. Suppose in number 10, I had this. I had 3x minus 2 times x plus 2 divided by 3x squared plus x minus 2. All right, what's the first thing you're going to do? Factor. Can you do anything to the numerator? No, because it's already in factored form, isn't it? But I can factor the denominator. And so when I factor the denominator, just go ahead and rewrite the numerator over because it's already written as factors. The denominator, the GCF is 1, so I'm going to go directly to the two binomials. Let's see, 3x. The 2 has to go here, and the 1 here. Last sign's negative, so the signs are different. The 2 has to be plus. Nope, 2 has to be what? Minus, and the The 1 has to be plus, right? Let's check it. What's the outer? 3x. What's the inner? Negative 2x. When I add them up, I get a positive x. And guys, usually when you simplify, your chances are, not always true, but chances are you're going to have common factors in both numerator and denominator. So if 3x minus 2 is one of the factors and x plus 2 is another factor, then one of those is probably going to repeat down here. It's not always true, but usually that occurs. All right, and then you reduce, and so what's the answer? X plus 2 divided by x plus 1. So don't say 1 times x plus 2. You know that 1 times x plus 2 is just what? It's just x plus 2. 1 times x plus 1 is just x plus 1.
We cannot reduce it here. No.
No, you cannot reduce. What would you reduce? There's the x is not a factor. So you cannot reduce the x's because x is not a factor. That's not. It doesn't say x times 2. It says what? X plus 2. So x plus 2 is considered the factor. All right, what if you had x squared plus 9x plus 14 divided by 2x squared minus 3x minus 2? All right, now remember the direction says simplify. Okay, so if I factor first, the numerator becomes x plus 7, x plus 2, right? The denominator becomes 2x, x, I think 2 and 1, right? Yeah. And then that'll be a plus 1 and a minus 2. Okay? So that's how you factor the denominator. But what do you notice about all your factors? Can it reduce anything? No. So then you would say that the original problem can't be simplified. All right, so cannot be simplified. So you just write cannot be simplified. But what if I had number 12? Let's do number 12. What if I change this to this? X squared plus 9x plus 14 divided by 2x squared, this time plus 3x minus 2. So the numerator stayed the same, right? The denominator changed. You see how it changed? The first one, it was a negative 3x. This one's a positive 3x. So when I factor it, though, the numerator stayed the same. So I'm going to say x plus 7 times x plus 2. But when I factor the denominator, that's 2x, x, 2 and 1 again. But this time, it's going to be 2x minus 1 and x plus 2. Can I simplify the original problem? Yes or no? Yes. I can simplify by reducing which factors? X plus 2's. And so what's the answer? X plus 7 divided by 2x minus 1. Okay, 13. Let's look at 13. Suppose you had in number 13, you had x to the 4th plus 3x cubed divided by x squared minus 3x minus 18. So x to the 4th plus 3x cubed divided by x squared minus 3x minus 18. All right, what about the numerator? How can you factor that? GCF. What's the GCF? X cubed. Okay, so I get x cubed times what? X plus 3. The denominator, when you factor this trinomial, the GCF is 1, so let's go to the two binomials. And what's going to work will be a 6 and a 3, and the 6 has to be negative, and the 3 is going to be positive. And always check The outer is 3x. The inner is a negative 6x. When I add them up, I do get negative 3x. Can I reduce anything? Yes, the x plus 3's. And so I get the answer to be x cubed divided by x minus 6. All right, let's do one more. One more, I'll give you a test back. Okay, 14. Suppose I had this. X squared. Yeah, then we find x squared plus xy minus 5x minus 5y divided by x minus 5. So let's see if you remember something from the previous test. How are you going to factor that numerator? Grouping. So in your test, you had the first two problems involve grouping. So let's go off to the side because it does involve some work. So I'm going to go off to the side. I'm going to rewrite the numerator. And then I'm going to factor by grouping. So when I group the first two and the last two, with the first two, what can I factor out?
X.
So I get x times x plus y. From the second group, now remember, the middle sign is subtraction, so you're going to factor out a negative GCF. So it'll be a negative what?
Negative 5.
Negative 5 times what? X plus, right? Because a negative times a positive is a negative. And remember, if you do this correctly, both parentheses, those two binomials better be the same. And so you get x plus y times what? X minus 5. So that's your numerator. So I'm going to rewrite the numerator as these two factors. So x plus y times x minus 5 divided by x minus 5. Now, can I reduce?
Yes.
Yes. So the x minus 5's divide out. So what's your answer?
X plus y.
X plus y. Okay? All right. So that was simplifying. We're going to do a little bit, we're going to do a few more problems with that next class period. But what we're coming upon is this. So still in the next class period, we're going to take these rational expressions and we're going to multiply them now. So first of all, you had to learn how to simplify. Now we're going to multiply them. It's not, if you can simplify this, you'll be fine with multiplying. All right? But you have to know how to do this before you can do the multiplying rational expressions. Okay.